September 27, 1941. Richmond, California. A single ship hull sat in the ways at the newly constructed Richmond Shipyard No. 1. Traditional. Naval architects predicted it would take 11 months to complete. The man overseeing construction had a different timeline. Henry J. Kaiser, an industrialist with no shipbuilding experience, told his engineers the vessel would launch in 150 days. They thought he was insane. What happened next would rewrite every assumption about American industrial capacity and help decide the outcome of World War II. By 1941, Great Britain was drowning. German U-boats sank merchant vessels faster than British shipyards could replace them. Winston Churchill later wrote in his war memoirs that the Battle of the Atlantic was the only campaign that truly frightened him. President Roosevelt understood the mathematics of survival. Britain needed 200 new cargo ships immediately, with hundreds more to follow. American shipyards, using traditional riveting methods, could deliver perhaps 50 ships per year. Henry Kaiser proposed something unprecedented: apply automobile assembly line techniques to shipbuilding. The Maritime Commission was skeptical. Traditional shipwrights called his ideas dangerous. Engineers warned that welded ships would crack apart in rough seas. But Kaiser had already revolutionized dam construction with the same methods critics now dismissed. This is the documented story of how one industrialist's manufacturing revolution, dismissed as insane by experts, saved 50 million man-hours of labor and built the steel bridge that carried Allied victory across the Atlantic Ocean. To understand why Kaiser's methods seemed insane, we must first understand traditional shipbuilding in 1941. Naval vessels had been riveted for centuries. The technique was proven, reliable, and slow. Skilled riveters worked in teams, heating metal rivets to orange-hot temperatures, then hammering them through pre-drilled holes to join steel plates. A single Liberty ship required approximately 250,000 rivets. The U.S. Maritime Commission's own production estimates, documented in their 1941 annual report, projected 355 days to construct a standard 10,000-ton cargo vessel using conventional methods. These weren't guesses. They reflected decades of shipbuilding data from established yards like Newport News and Bethlehem Steel. Kaiser proposed welding instead of riveting. Welding was faster, but the maritime industry considered it fundamentally unsuitable for ocean-going vessels. The American Bureau of Shipping's 1940 standards expressed concerns about weld integrity under stress. Naval architects worried about catastrophic hull failure. These weren't baseless fears. Several welded vessels in the 1920s had experienced cracking. Kaiser didn't care about precedent. He cared about production data. His engineering team, led by shipbuilder John Riley, had studied welding failures and identified the problem: improper technique and inadequate quality control. Modern electric arc welding, when executed correctly with proper steel composition, produced joints stronger than the surrounding metal. Laboratory tests at the Kaiser Company facilities in Oakland confirmed this. The data was irrefutable. On November 14, 1941, Kaiser's team presented their production plan to the Maritime Commission. The proposal detailed a modular construction system, prefabricate entire ship sections in different areas of the shipyard, then weld them together on the ways. Commission Chairman Admiral Emery Land's response was recorded in the meeting minutes, now archived at the National Archives. Gentlemen, this schedule assumes we can build ships like automobiles. We cannot. Kaiser had 6 months to prove otherwise. The first keel was laid that same week. Richmond Shipyard No. 1 occupied 165 acres of tidal mudflats on San Francisco Bay. In January 1941, nothing stood there except marsh grass. By December, 7 massive shipways dominated the waterfront, each capable of assembling a complete cargo vessel. This wasn't traditional shipyard construction. Kaiser applied principles from his Boulder Dam project, where he'd revolutionized concrete pouring through coordinated parallel workflows. The Liberty ship design itself came from a British template, the Ocean-class freighter. The U.S. Maritime Commission modified this design for American production, creating a standardized 441-foot vessel capable of carrying 10,000 tons of cargo. Every Liberty ship would be identical, enabling the mass production Kaiser envisioned. Traditional shipyards built vessels from keel to superstructure in sequential steps. Kaiser's method was radically different. Richmond Shipyard divided Liberty ship construction into 250 prefabricated sections. While one team laid the keel on the shipway, separate crews across the yard simultaneously welded bulkheads, assembled deck sections, and constructed the engine house. Each section received complete welding, piping, and electrical work before installation. The first vessel, hull number SS001, began assembly on December 8, 1941, the day after Pearl Harbor. William Ward, a structural engineer from the Kaiser Company, documented the initial construction process in his technical diary, now preserved at the Richmond Museum of History. His entry from December 15th records: welding crews completed 3 bulkhead sections today. Traditional method would still be riveting the keel. Superintendent believes we'll launch in 5 months. 5 months represented revolutionary speed. But Kaiser wanted faster. Kaiser's innovation wasn't just technical. It was human. Traditional shipyards employed journeymen trained through 5-year apprenticeships. These skilled craftsmen understood every aspect of ship construction. They were also scarce. The U.S. had perhaps 15,000 qualified shipwrights in 1941. Kaiser needed 90,000 workers. His solution: break complex tasks into simple, repeatable steps that could be taught in weeks rather than years. The same principle Henry Ford had applied to automobile manufacturing. Richmond Shipyard established training facilities teaching single specific skills. One worker learned only how to weld vertical seams. Another specialized in horizontal welds. A third focused exclusively on overhead welding. Each became extremely proficient at their particular task. The Maritime Commission's training program documentation, preserved at the National Archives, shows Richmond Shipyard graduated 1,200 welders in January 1942 alone. These weren't master craftsmen. They were farmers, store clerks, and housewives who completed 3-week intensive courses. Quality inspectors followed every welder, using X-ray equipment to verify weld integrity. Defective welds were ground out and redone immediately. This inspection system, documented in Kaiser Company quality control reports from 1942, maintained structural standards while enabling rapid construction by semi-skilled workers. Critics predicted disaster. April 14, 1942. SS001, named Patrick Henry, slid down the ways at Richmond Shipyard exactly 127 days after her keel was laid. The traditional estimate had been 355 days. The War Department sent observers to document the launch. Their report, filed April 20th and now declassified, noted, "Vessel appears structurally sound. Time savings represent approximately 60% reduction in construction period. If maintained across production, this methodology would multiply projected American cargo capacity by factor of 2.5. Admiral Land, the same man who dismissed Kaiser's automobile comparison 5 months earlier, delivered remarks at the christening ceremony. News reports from the San Francisco Chronicle, April 15, 1942. Quote his statement: "I didn't believe this was possible. The data proves I was wrong." Patrick Henry underwent sea trials in May 1942. Naval architects monitored stress points, particularly weld seams, during rough weather tests off the California coast. The ship performed flawlessly. By June, Richmond Shipyard had 3 more vessels under construction. Kaiser projected 30 completed ships by year's end. The Maritime Commission authorized construction of Richmond Shipyard No. 2. What happened next defied every prediction. Kaiser didn't just maintain his production schedule. He accelerated it. The prefabrication system allowed continuous optimization. Each completed ship provided data on bottlenecks and inefficiencies. Kaiser's industrial engineers, many recruited from his dam projects, analyzed every step. By August 1942, Richmond Shipyards 1 and 2 combined had reduced construction time to 82 days. The key breakthrough came from parallel assembly. Joseph Barnes, a production supervisor at Richmond No. 2, explained the system in a 1943 interview preserved in the Bancroft Library's Kaiser Industries collection. We had 7 ways running simultaneously. The moment a hull launched, we'd lay a new keel that same afternoon. While that keel was being assembled, we had 250 sections being prefabricated in the yard. Nothing stopped moving. This continuous production flow required unprecedented coordination. Kaiser implemented a centralized planning system tracking every section through fabrication, inspection, and installation. Detailed production charts, samples of which are preserved in the National Archives' Kaiser Company records, showed the location and status of every component for all 7 ships under simultaneous construction. Traditional shipyards built ships sequentially. Kaiser built them simultaneously. By December 1942, Richmond Shipyards achieved a sustained production rate of 1 completed Liberty ship every 30 days per shipway. With 7 ways operating, Richmond alone produced approximately 7 ships per month. The U.S. Maritime Commission's December 1942 production report documented the national impact. Kaiser methods, now adopted across 15 shipyards, increased national production capacity from projected 500 vessels annually to actual 1,800 vessels annually. This represents manufacturing capability increase of 360%. Kaiser expanded further. By 1943, he operated shipyards in Richmond, Portland, and Vancouver, employing over 200,000 workers. But the most astonishing demonstration was yet to come. November 8, 1942, Richmond Shipyard No. 2. Kaiser issued a challenge to his workforce: build 1 Liberty ship in under 1 week. This wasn't publicity stunt. It was calculated strategy. Kaiser understood that breaking psychological barriers motivated workers and silenced critics simultaneously. More importantly, it tested the absolute limits of the prefabrication system. The target vessel was Hull 440, to be named Robert E. Peary. Every section was prefabricated and pre-inspected before keel laying. Kaiser coordinated all 7 Richmond No. 2 shipways to focus resources on this single vessel. At 12:01 a.m. on November 12, 1942, the keel was laid. What followed was documented minute by Maritime Commission observers, whose detailed timeline report is preserved in Record Group 178 at the National Archives. Hour 1 to 12. Keel assembly and first bulkhead sections installed. Hour 12 to 24. Midship sections welded. Propeller shaft housing installed. Hour 24 to 48. Forward and aft sections assembled. Deck plates positioned. Hour 48 to 72. Superstructure installed. Engine room equipment lowered into position. Work continued around the clock. Welding crews operated in 4-hour shifts. Inspection teams verified each weld before proceeding. The entire Richmond workforce focused on supporting this single ship. Hour 72 to 96. Final deck sections welded. Masts and cargo booms installed. Crew quarters completed. At 3:15 p.m. on November 15, 1942, exactly 4 days, 15 hours, And 29 minutes after keel laying, SS Robert E. Peary slid down the ways. A complete ocean-going cargo vessel had been constructed in less than 5 days. Newsreel footage from Paramount News, November 1942, preserved at the Library of Congress, shows the launch ceremony. Admiral Howard Viscari of the Maritime Commission stated on camera, "I have witnessed what I would have called impossible 1 year ago. This vessel represents industrial capability that exceeds anything in human history." The Robert E. Peary underwent accelerated sea trials. Coast Guard inspectors examined every system. On November 28, she received certification for Atlantic convoy duty. The speed record had one purpose: prove that American industrial capacity could overwhelm any threat. But speed created problems. The Robert E. Peary record required unsustainable worker concentration. Kaiser's own production reports from December 1942, archived at the California State Archives, documented the aftermath. Exceptional construction pace resulted in 47 workplace injuries during a 5-day period. Standard monthly injury rate is 38 per shipyard. Record vessel construction demonstrated capability limits, but not sustainable practice. Kaiser never attempted the 5-day record again. The sustainable production pace remained approximately 30 to 40 days per vessel. This still represented revolutionary speed compared to the 355-day traditional timeline, but it acknowledged human limits. Workplace safety became a central concern. Margaret Dawson, a welder at Richmond No. 2, wrote in a letter to her sister dated March 15, 1943, now preserved in the Rosie the Riveter World War II Home Front National Historical Park archives. "They push us hard, but not like that November week. That was crazy. Now they care whether we live to see next ship launch." Kaiser implemented comprehensive safety programs by mid-1943. Accident rates declined 40% while production increased. Meanwhile, a serious problem emerged. In January 1943, 3 Liberty ships suffered catastrophic hull fractures. SS Schenectady broke completely in two while docked in calm waters in Portland, Oregon. Naval architects' worst predictions appeared validated. The fractures occurred along weld seams. Critics immediately blamed Kaiser's welding methodology. Traditional shipbuilders argued that riveted construction would have prevented this failure mode. Congressional committees demanded investigations. Production slowed pending engineering reviews. The actual cause was more complex. Constance Tipper, a metallurgist at Cambridge University, analyzed fracture samples under contract with the U.S. War Department. A technical report submitted June 1943 and now declassified identified the problem: brittle fracture in steel at low temperatures, initiated at stress concentration points in the hull design. The issue wasn't welding versus riveting. It was steel composition and hull design. Tipper's analysis showed that the Liberty ship hull design included sharp corners at hatch openings. These corners created stress concentration points where cracks could initiate. In cold water, the specific steel alloy used became brittle enough for cracks to propagate rapidly. The solution required 2 modifications: change steel composition to remain ductile at low temperatures, and add crack arrestor straps at critical stress points. These straps, essentially steel bands riveted perpendicular to potential crack paths, stopped fracture propagation even if cracks initiated. Kaiser implemented both changes by July 1943. All existing Liberty ships received retrofitted crack arrestor straps. New construction used improved steel and modified hatch designs. The fracture problem ended. Of 2,710 Liberty ships ultimately built, only 12 suffered serious structural failures after the 1943 modifications. The success rate exceeded 99.5%. By 1944, Kaiser's methods had revolutionized American shipbuilding entirely. 18 shipyards across the United States adopted the prefabrication system. The Maritime Commission's 1944 annual production report documented the results. Calendar year 1944, 2,247 cargo vessels completed. This represents greater tonnage than total American merchant marine existing in 1939. America built more cargo capacity in 1 year than existed before the war began. Richmond shipyards alone completed 747 vessels between 1942 and 1945. At peak production in 1944, all Kaiser shipyards combined launched an average of 1 Liberty ship every 24 hours. The man-hour savings were staggering. Traditional riveting required approximately 650,000 man-hours per vessel, based on pre-war production data from established shipyards. Kaiser's welding method reduced this to 150,000 man-hours per vessel by 1944. Multiply that 500,000 man-hour savings across 2,710 Liberty ships built. The total exceeds 1.3 billion man-hours saved. But the Maritime Commission's labor analysis, conducted in 1945 and preserved in the National Archives, calculated the broader impact differently. They examined not just direct construction labor, but the entire supply chain: steel production, component manufacturing, transportation, and support services. Their conclusion: Kaiser's methods reduced total industrial labor investment per ship by approximately 60%. Applied across all Liberty ship construction, this represented approximately 50 million man-hours of industrial labor made available for other war production. Those 50 million hours built tanks, aircraft, ammunition. They represented industrial capacity redirected to winning the war. The Liberty ship program existed for one purpose: defeat German U-boats through mathematics. Admiral Karl Dönitz, commander of German U-boat operations, understood tonnage warfare precisely. His strategy, documented in German naval records now held at the Bundesarchiv in Freiburg, was straightforward: sink merchant ships faster than the Allies could replace them. In 1942, German U-boats sank 1,664 Allied merchant vessels, totaling 7.8 million tons. British and American shipyards completed approximately 7 million tons of new construction. The Allies were losing. Dönitz calculated he needed to maintain a sinking rate above 700,000 tons per month to strangle Britain's supply lines. If he could sustain this rate for 18 months, Britain would collapse. Then, American production accelerated. The U.S. Maritime Commission's monthly production reports from 1943 show the turning point. American yards alone completed 19.2 million tons of new merchant shipping in 1943. This exceeded total Allied losses for the year by a factor of nearly 3 to 1. Dönitz recognized the implications immediately. In a conference with Hitler recorded in German Naval War Diary entries from March 1943, he stated, "The enemy builds ships faster than we can sink them." The tonnage war is lost. Liberty ships flooded the Atlantic. By mid-1943, Liberty ships formed the backbone of every major Allied convoy. These vessels weren't glamorous. They were slow, cramped, and uncomfortable. Crews called them ugly ducklings, but they carried everything: tanks, aircraft, ammunition, food, fuel, and the raw materials of industrial war. SS Jeremy O'Brien, completed at New England Shipbuilding in June 1943, exemplifies the typical Liberty ship's contribution. Her deck logs, preserved aboard the vessel now serving as a museum ship in San Francisco, document 127 Atlantic crossings between June 1943 and June 1945. Across those crossings, she carried approximately 160,000 tons of cargo to Britain and the Mediterranean. One ship, 2 years. enough material to supply an entire armored division. Multiply that productivity across 2,710 Liberty ships, and the scale becomes clear. The Port of New York's cargo manifests from 1944, archived at the New York City Municipal Archives, show peak monthly exports of 3.7 million tons departing for Britain in June 1944, the month of the Normandy invasion. The majority moved aboard Liberty ships. Operation Overlord, the D-Day landings, required positioning 7 million tons of supplies in Britain before the invasion began. Liberty ships carried most of that material across the Atlantic through 1943 and early 1944. After D-Day, Liberty ships continued supplying Allied armies advancing across France. SS Arthur Middleton, completed at Kaiser's Richmond Yard in November 1943, carried ammunition directly to Omaha Beach in June 1944. Her logs record unloading 8,000 tons of artillery, shells and small arms ammunition over 10 days while anchored offshore. This pattern repeated across hundreds of vessels. Liberty ships proved equally vital in the Pacific. The vast distances of the Pacific theater created logistical challenges exceeding even the Atlantic. From San Francisco to Brisbane, Australia measured 7,400 miles. Every gallon of fuel, every replacement aircraft, every artillery shell had to cross that ocean. The U.S. Army Service of Supply documented the Pacific Logistics Challenge in their 1945 operational report. Pacific operations required moving 1.5 million tons of supplies monthly across distances averaging 6,000 miles. Liberty ships provided 60% of this transport capacity. SS Richard Henry Dana, completed at Kaiser's Portland Yard in February 1943, made 17 round trips from California to Pacific Islands between March 1943 and August 1945. Her deck logs show she transported construction equipment, aviation fuel, medical supplies, and reinforcement troops across those voyages. Admiral Chester Nimitz's operational plans for the island-hopping campaign relied on specific cargo ship availability projections. The faster Liberty ships entered service, the faster Nimitz could advance across the Pacific. Documents from Nimitz's command archives at the Naval History and Heritage Command show his April 1944 recommendation to the Joint Chiefs of Staff. Accelerated merchant ship construction enables compression of operational timeline for Philippines liberation by 3 months. Material supply no longer limits Pacific advance rate. American industrial capacity, converted to floating cargo holds, determined Pacific campaign tempo. Not all Liberty ships survived. Of 2,710 built, approximately 200 were sunk by enemy action. German U-boats, surface raiders, and aircraft claimed most of these vessels. Japanese submarines and aircraft accounted for additional losses in the Pacific. SS Richard Bland, completed at Richmond in August 1942, was torpedoed by U-613 in the North Atlantic on February 27, 1943. She sank in 14 minutes. 42 crew members died. 7 survived. These losses were anticipated and calculated into production planning. Kaiser understood the mathematics. Build ships faster than they could be sunk, and the Allies would win through sheer volume. The strategy succeeded. U.S. merchant marine casualties were heavy, with approximately 9,500 merchant sailors killed during the war. But the ships kept coming. For every Liberty ship sunk, 3 more entered service. By 1945, so many Liberty ships operated that the Maritime Commission began preserving dozens in reserve fleets. These vessels, anchored in protected harbors like Suisun Bay, California, represented surplus capacity. America built more cargo ships than the war required. Henry Kaiser received the Maritime Commission's Distinguished Service Medal in 1945. The citation, preserved at the Harry Truman Presidential Library, reads, "For exceptional leadership in developing manufacturing techniques which multiplied American shipbuilding capacity by factor of 4, enabling Allied victory through superior logistics." Admiral Ernest King, Chief of Naval Operations, wrote to Kaiser in May 1945. His letter, archived in Kaiser's papers at the Bancroft Library, stated, "History will record that American industrial genius won this war." You personified that genius. The man they'd called insane had built the bridge to victory. When Liberty ship production ended in 1945, the numbers were extraordinary. 2,710 vessels completed, 18 shipyards operating at peak, 700,000 workers employed, 29 million tons of cargo capacity created. But the raw numbers only hint at the transformation. In 1939, building a single merchant ship required specialized craftsmen trained through multi-year apprenticeships. The work demanded hand-fitted rivets, sequential construction, and nearly a year of labor. By 1945, semi-skilled workers with weeks of training assembled prefabricated sections using electric welding. Construction time dropped to weeks. Quality equaled or exceeded traditional methods. Henry Kaiser didn't invent welding. He didn't design the Liberty ship. His innovation was applying industrial production principles to a centuries-old craft that resisted change. The Maritime Commission's final report on wartime construction, published in 1946, concluded, "Prefabrication and welding methodology developed for emergency shipbuilding program represents most significant advance in marine construction since introduction of steel hulls in 1880s. That advancement shaped the post-war world." Modern cargo ships descend directly from Liberty ship construction techniques. Modular section assembly, electric welding, and parallel workflow systems remain standard practice in every major shipyard globally. Many Liberty ships themselves continued operating decades after the war. SS Jeremy O'Brien and S. John W. Brown survive today as museum ships, representing the 2,710 vessels that carried Allied victory across the oceans. Kaiser himself moved on to other industries. He applied the same production principles to automobile manufacturing, creating Kaiser Frazer Motors. Later, he revolutionized healthcare delivery by founding Kaiser Permanente, still one of America's largest healthcare systems. But his greatest contribution remained those 2,710 ships. The 50 million man-hours saved through efficient production weren't just statistics. They represented tens of thousands of workers freed to build aircraft, tanks, and ammunition. They represented industrial capacity multiplied through innovation. Admiral Land, the skeptic who told Kaiser in 1941 that ships couldn't be built like automobiles, wrote his final assessment in his 1948 memoir, Winning the War with Ships. I was wrong. Kaiser proved that impossible simply meant no one had tried yet. His methods didn't just build ships. They demonstrated that American industrial capacity, properly organized, exceeded any limit our enemies imagined. In September 1941, when Henry Kaiser first proposed building cargo ships in 150 days, experts called him insane. By September 1945, his insane methods had constructed the largest merchant fleet in human history, carried 15 million American service members overseas, delivered 270 million tons of cargo, and built the steel bridge that transported Allied victory across both oceans. Sometimes insanity is just vision that arrived early.